Okay, class, picking up where we left off at. We had 3,200,000,000 divided by d squared. So now what I need you all to do is to copy this down because I'm going to have to do some erasing here. So this is our formula. So now, or you can pause it. So now what I'm going to do, I'm going to erase this. So let me rewrite this here. Okay, so we had W is equal to 3,200,000,000 all over d squared. So I can erase this bottom equation as well. Okay, now this problem asks us here, it says, how much would a 200-pound man weigh 1,000 miles above the surface of the earth? So now we have to substitute. So now we would have W, what we want to sound, a 200-pound man weigh 1,000 miles. Okay, so we're going to end up solving for W. So we had W is equal to 3,200,000,000 divided by 4,000 miles. Okay, now look here. The radius of the earth is 4,000 miles. But this is 1,000 miles above the surface of the earth. So we have to add these two values together. So our D would be 5,000 miles. And we would square that because we're going 1,000 miles above the earth. So now we would have W is equal to, now we would have this, well, let me put this in a calculator. Might as well utilize our resources. So we would have our, let me come up here, have our 3,200,000,000 divided by, in parentheses, I'll put 5,000, and I will square that. And this will give us 128. So the weight would be 128 pounds. So I guess that's the cure for weight loss. Just go above the earth. So you can lose some weight here. So the weight is 128 pounds. So now we scroll down here to example 7. It says the number of hours H that it takes M men to assemble X machines varies directly as the number of machines and inversely as the number of men. If 4 men can assemble 12 machines in 4 hours, how many men are needed to assemble 36 machines in 8 hours? So we would have H is equal to K times X all over M. So now we have here that H is 4. That's how many hours we have. We have K, and then we will have 12. X would be 12, and then we will have 4 for the men. So now we need to get K by itself. So of course we know we will multiply each side. Well, we can divide this. Doesn't 4 and 12 go into each other evenly? So we have 4 is equal to 3K. We divide each side by 3, and 4/3 is equal to K. So now our new formula, which would be H is equal to 4X over 3M. Because we know this 4 will remain with the X, and the 3 will go down with the M. Does everyone follow that? Okay, so now we will go through and substitute. So we would have 8 men is equal to 4 times the 36 machines all over, we have 3M. Now, we need to get, well, actually, we have the hours. We need to find out how many men we actually have. So we'll multiply each side by 3M, because we need to get this 3M from our denominator. So it'll be 24M is equal to, this 3 times M will simplify out. 4 times 36 is 144. We divide each side by 24, and M is equal to 6 men. And that is our final answer. Any questions on example 7? Okay, now we come to example 8. It says here, explain how G would change if D were double. Now listen, if we double D, which means that we're going to multiply by D, right? How do you think that would affect G? Any questions? Well, let's do this. Let's say we had G, and let's use some numbers. This is what I used to do when I first was learning algebra. Let's just say we had 5. Well, let me use smaller numbers to reflect the square and the, let's say we have 5 squared, and then let's make D 3. And then Z, let me see, let's just make Z 25. Okay. All right, so we look here. We had 25 times 27. And then we would divide that by 25. Okay, so our answer here would be 27, right? Okay, now we're asked, explain how G would change if D were double. So we know 3 represents our D, right? So what we would do is this. We would add G is equal to 5 squared times 2 times 3 cubed all over 25. So now we add G is equal to 25 times 3 cubed is 27 times 2 is 54. And that's still all over 25. So G would be 54. So what happened here with 27 and 54? It doubled. So you could say it doubles. Now, what you could do in mathematics, what I just did here, this was a mathematical sentence. So this would explain, if you just put a period at the end, this would explain your reasoning for why you say it doubles. Does everyone follow that? Okay, now it says explain how G would change if D were halved. All right. So basically, if you notice here, it's varying directly, right? So if it doubles here, then it will be half of the amount. Now that we know that it's varying directly. Okay, now it says explain how G would change if Z were triple. Okay, now, since we have these previous problems that we've done, why don't we do this? Why don't we take what we did, still using the numbers. It'll be 5 squared times 3 to the 3rd power. Well, that's G equals. All over, we said Z would be 25. And we said what would happen if Z was triple. So now we had 25 times 27 all over 75. Now we know 25 goes into 25 once. 25 goes into 75 3 times, right? 3 goes into 3 once. 3 goes into 27 9 times. So we know our final answer would be 9. So we could go back and compare it to what we originally had. Our original answer was 27, right? So that means that, what would it be? 1/3. It'll be 1/3 of the original answer. Okay, it says, explain how G would change if Z were cut evenly in thirds. Since we know by multiplying by 3 it'll cut the answer by 1/3, what would it do to the answer here? Yes. The answer of G would triple. And let's go back here to C. I want to make one change to C just to make it reflect. It'll be 1/3 of G instead of just saying of the original answer. It'll be 1/3 of G just to have it in terms of of G. And going back up here to A and B, we can just say it doubles G. It will be half of the amount of G. And then this finishes out 12.8.